So there you have it, the various options for deployment in ASP.NET. We started off with a look at deployment of code in your web application projects or websites, and there are several options there: deploying to the app code directory, just as leaving the source code in place, compiling a separate class library project and deploying it into your bin directory, or alternatively, signing your assembly and deploying it in the global assembly cache and referencing that assembly from within your configuration file. We then talked about the various deployment options of ASP.NET websites, including the source mode, which is just an Xcopy deployment, all binary, which takes all of your ASPX content and all of your source code and compiles them into assemblies and deploys them in a bin directory, or the updatable mode, which is a hybrid of the two that gives you updatable ASPX files but completely precompiled source code. And then we talked about web application projects, which give you another option for building web applications in ASP.NET, which are distinct from websites. And this gives you a real project file with all the benefits that come from that. And then finally, we looked at web deployment projects that fill some of the holes that were still left when you are deciding how to deploy things and which type of project you're using. Web deployment projects make sure you still have all options available to you in terms of what style of deployment you want to use. Let's start our look at deployment by talking about the various options you have when packaging code as part of your web application. So I'm going to start just by creating a new website here, and we'll use this as a platform to experiment with various options for code packaging. So let me just call this code test. And the first option you have, and the one that you've probably used most often if you've done this already, is to drop code files directly into the app code directory. And that's the one, in fact, that is encouraged with the Visual Studio website model. So if we go ahead and add a new class to our website, and let's call this myutils, notice we are prompted asking us if we want to place this code into the app code directory so that it will be compiled as part of the request processing sequence. And let's go ahead and say yes, we do. So let's go ahead and create this class with a couple of functions in it so we can do something interesting. I'm going to wrap it in a namespace, and I'm actually going to change the type of the class to be a static class because I'm only going to include public static methods in it. And let's do a public static string function that returns a string, and it's going to do let's call double string input, and we're just going to return input concatenated with input. So we'll just double the string and return it, something simple. Okay, so if I wanted to use this class in part of my application, I could go to my main page here, and let's say enter a string and put a text box in there for someone to enter a string into. And let's go ahead and give them a button to invoke our double function so we can see that happening. So I'm going to go ahead and add a handler for the button here. And inside of that handler, we'll just invoke our method of our utility class. So let's go ahead and put a using for the namespace in here. And I'm going to say ps or myutils dot double string, and we'll do textbox1 dot text like so. And actually what I want to do is set this into a label so we can see the results. So let's add one more thing up here, which is going to be a label, and we'll just print to that and show the results. So label1.text equals the result of calling that. Okay, so we should now have a page that will double the string. Let me just change the text on the button here to say double. Let's go ahead and run that page, and we should see our utility class kick into gear. As we click on double, it doubles the string. Perfect. Okay, so let's take a look at another option for code packaging. That's sort of the simplest model, and there are many good reasons to go this route. But let's go ahead and try adding a separate solution or a separate project. So I'm going to create a new project, and I'm going to create a class library project. And I'm going to put this up in the a sibling directory to my website. And let's just call this myutils. And inside of the class library, let's go ahead and replicate that class here. And we'll call it myutils2, so it's slightly different. And let's go ahead and grab this function that we had before, drop it into here, make this a static class as well, and that should be good to go. So here's the second option you have for packaging, which is to create a separate project that is maintained distinct from your website, and go ahead and compile that. And what you need to do to reference that, like you would any other precompiled assembly, is deploy it into your bin directory in your website. Now we currently don't have a bin directory, but if we go ahead and add a reference to the class library assembly that we have as part of the same solution, it will generate a bin directory for us and make sure we have the latest copy of that assembly. So I'll go to the Projects tab and include a reference to that utility class. Notice it generated the bin directory here along with the assembly copied from the most recent compilation. So if I go back into my code behind here, and let's change this from myutils to myutils2, which is the one that was brought in from the assembly, the secondary assembly. Go ahead and compile it. Seems to work. Good. And we run this. Everything should work as it did before, although we're calling into a separate code base. So those are two options. You can just deploy your code directly to the app code directory, or you can create a separate project, class library project, and reference the generated assembly in the bin directory. And there is a third option you can use, which is to deploy your assembly to the global assembly cache and have it shared across multiple applications. And we'll take a look at that one next. Now, the third option for deploying code as part of your site is to package up your code into a separate assembly and then deploy that to the global assembly cache. And this can often be useful, especially if you want to share utility classes or classes in general across applications on a single machine. You can deploy once to the global assembly cache and have all of the applications of that machine refer to that globally deployed assembly. However, you do want to do this only in cases where it makes sense to deploy globally for a couple of reasons. One is it's going to complicate your installation on the server. It's going to require a separate administrative step to deploying your application. You must register the assembly in the global assembly cache. And it's also going to require a little bit more configuration setup in your class library project. You're going to have to fully sign the assembly with a public-private key pair, and then you'll have to begin managing key pairs as part of your compilation process as well. But the advantages are you get machine-wide deployment, so you have a shared assembly, and you also have support for version-aware loading, which can be useful if you are going to be versioning your assembly and want to make sure that different sites are using the version that they were compiled against originally. Now, I'll show you an example of doing this with Visual Studio in just a moment, but I want to briefly show you the underpinnings of signing an assembly. And we're not going to go into a lot of detail here. We could really spend an entire module talking about assembly, loading, and signing, but just enough to get you started. So the process of signing an assembly so that it can be deployed in the global assembly cache involves generating a public-private key pair. And the simplest way to do that is to use this command line utility that ships with .NET called SN, stands for strong name. And you just run SN-K to generate a key and then give it the file name, and that will spit out a new public-private key pair for you. And then you generally want to keep that in a safe location so that no one else can sign assemblies with that same signature. And then when you compile your assembly, you reference the public-private key pair as part of an assembly level attribute, assembly key file, and you typically will include a version number as well to synchronize the assembly as you evolve it. So let's go ahead and go back to our demonstration and take a look at signing that assembly. So I'm not going to use the command line utilities here as I showed in the slide. I'm just going to use the support built into Visual Studio 2008 for doing this. So I'm going to get the properties on the class library project, and notice one of the options in the left-hand tab here is the signing. And if you go ahead and click on sign the assembly, there is an option here that will generate a strongly typed or a public-private key pair for you, and we'll give it the name of pubpriv.snk, And if you want to, you can protect the file with a password. I'm not going to bother right now. And that will set up the signing for us. Now, the one other thing you want to do is you want to set up the versioning. And by default, the versioning will be in place already. They will have default values for you, but you may want to go back and make some modifications to those values. So you'll find those values inside of your properties directory in your class library project in the assembly info file. This is also accessible from the front level of the project page, assembly information. So here are all the values inside of the assemblyinfo.cs file. You can modify them there, or you can go through this interface here, which lets you modify the values as well. So let's go ahead and annotate this with a company name. Copyright is fine. Version number is fine. Version 1.000, and we should be good to go. Okay, so if we compile this assembly now, that will generate a strongly named assembly. And technically, I could still deploy this just as I have it here and have this assembly referenced in the bin directory. But what's interesting about deploying an assembly to the GAC is it will always look to the GAC first to load an assembly. So it would actually not load the assembly that was in our bin directory. So to put this assembly in the GAC, I'm going to go bring up a command shell and go to our directory that contains our new assembly, which is my utils directory. Go to the bin debug directory, and I'm going to run a utility called gacutil -i for insert and myutils.dll, and that will insert my assembly into the global assembly cache. Now, if you want to see that insertion, you can find your global assembly cache under Windows Assembly, and we should see inside of the shell extension that shows us all the registered assemblies in the GAC our myutils assembly deployed there. And there it is right there. There is an interface for doing this, by the way. If you want to just grab your assembly and drag it onto this window, the assembly window, that will deploy it as well. But typically you're going to be setting up some sort of script to deploy these global assembly cache assemblies to your server. And to do that, you're going to want to run this gacutil utility to install it. Okay, so next we'll take a look at how to reference a global assembly cache deployed assembly inside of your website. Now that we have our assembly deployed in the global assembly cache, let's take a look at how to reference that assembly from within an ASP.NET website. Now, there are actually a couple techniques. The first technique, if you're dealing with a website that is compiling its source code, so this is specifically going to be a web application project that we'll be looking at in a few slides here, all you need to do is reference the original assembly directly, and at runtime it will load the assembly from the global assembly cache. So we're not going to look at that example right now because we're dealing with a website. So in a website model where you have code in your app code directory or code in your code behind pages that is going to be compiled at request time, you need to make sure that the assembly is referenced in your web.config file. And to add a reference to a global assembly cache assembly in your web.config file, you go under the compilation element, and inside of there you'll find an assemblies element, and you just use the add element to place your assembly reference within the config file. Now, when you're referencing a strongly named assembly, you're going to need to use the full 4-part name of the assembly, which includes the short name, that's the actual file name, the assembly, the version number, the culture, which for code assemblies is always neutral, and the public key token, which I will show you how to extract in just a moment. So let's go back to our demo and try referencing the global assembly cache assembly from within our website. The first thing I'm going to do is remove the reference that I added earlier that copied the assembly into my bin directory. Now this is, again, sort of interesting because technically having this in the bin directory is a legitimate way to reference the assembly in the deployed global assembly cache. But it's probably not good practice because if you have the assembly in the bin directory, it's going to look to most people like that's the one you're referring to, even though at runtime it's actually going to reach up into the global assembly cache to grab it. So what I would recommend is removing that reference if you do plan on referencing the assembly from the global assembly cache. So let's bring up the property pages, and under references, I'm going to remove the myutils assembly reference. Okay, so that takes out the assembly from the bin directory. And then what we're going to do is add a reference in our config file. So I'm going to scroll down to the compilation settings, and there actually should be a couple of assemblies already referenced if you're using the standard ASP.NET website in Visual Studio 2008. So what I'm going to do is just copy one of those assembly references and change the string so that it matches our own assembly, which is myutils. That was the name of the assembly, and the version was 1.000. Let's make that change. Culture is going to be neutral, and then here's the one that's questionable. How do we get this public key token? So the safest way to get that, to make sure you actually have the right thing, is to go to the global assembly cache directory, which is your Windows/assembly directory, locate your assembly there, and in there you will see the public key token. And if you bring up the properties on your global assembly cache deployed assembly, you can actually copy the public key token from within the properties window. So Control-C to copy it, go back to your config file, and drop that in at that location. The reason I say that's the safest way is there is another way, which is to use the SN utility. And the SN utility has a way of extracting a public key token from an existing assembly, so you can actually run that against your compiled assembly. But some of these command switches are a little bit confusing because they apply both to assemblies and to public-private key pair files. And if you get them mixed up, you get no warning, but you just get the wrong key pair. So I highly recommend using the technique I just showed you to extract the public key token. Okay, so we should now have a reference to the assembly, the global assembly cache deployed assembly, and our code doesn't have to change at all. So our code right here, notice it still should work fine if we compile, because that configuration file reference in the global assembly cache assembly should suffice. And if we run this application, it should still work fine, even though we have no local assembly deployed in the bin directory. And this, again, has the advantage of you can have as many applications on a given machine referencing this assembly from a single source, and then any updates you make to that assembly will potentially be reflected in all of those applications. One of the advantages of deploying to the global assembly cache is that there is support for versioning of assemblies and side-by-side deployment of those different versions. Now, this is not true when you're deploying assemblies into your local bin directory. That's a much more rudimentary deployment model where whatever is in the bin directory is the assembly that you're using, and there's no question that's what you're going to. So generally, you put things in there that are very application specific and that you tend to rebuild as part of your web site every time you build and deploy. So versioning applies to assemblies that are in the GAC. And basically, when you compile the assembly, you can mark it with a version number like you saw, and then if you make a change that might have implications on the clients that are referencing the assembly, it's wise to increment the version number, and then you can decide which part of the version number to increment depending on how significant the change is that you end up making. I should mention it is technically possible to have clients automatically update to a newer version using something called version binding policy. As you build your assembly, you can deploy with part of the assembly a binding policy so that if someone asks for version 1.0, you actually end up giving them 1.1. We're not going to get into the details of that, but I just wanted to let you know that was possible. By default, however, clients that target a specific version are always compiled against that version, and they're guaranteed that that is the one that they're going to be accessing. And that gives you a level of confidence that nothing will have changed since you actually did your testing against that version. So let's go back and try versioning the assembly in our small example here. So I'm going to go open up the class definition where we have our double string method, and let me change that method to actually triple the string, just for something we can see very easily. So our double string method is now actually going to concatenate it 3 times, and I'm going to go and increment the version number from 1.0 to 1.1 inside of our assembly info file. And let's go ahead and compile that now. Okay, and let's go redeploy it. So I'm going to gacutil -I for install myutils.dll, which should be version 1.1 now. And if I go refresh this assembly cache directory under Windows Assembly, we should see in there two different versions of the myutils assembly. One is the 1.0 version we deployed initially, and the other is the 1.1 version we just deployed. So it does support side-by-side deployment, and they achieve this using a directory structure inside of this directory that contains the public key token and the version number as part of the directory path. Okay, so now the question is, what's going to happen if I run the application, the website that was referencing that global assembly cache assembly? And let's go try it. So I run it with a test string here, and notice we're getting the double behavior just like we did originally. And the reason for that is our website is still referencing the 1.1 version of this 1.0 version of this assembly. So if I wanted to take advantage of new features that were added to an assembly that was deployed in the GAC, I could go into my config file, update it to point to the new version. So when I run my application again, we should be pointing to the new version so that when I put a string in to double it, we actually get a triple instead of the original doubling. So you get what you ask for. Whatever version you're bound to is the one that you will be accessing, modulo version policy, but hopefully the developer has accounted for that. And it gives you a nice way of deploying code globally to the machine that is used across multiple sites or multiple applications. Let's turn our attention now to the actual deployment of your website to a live server. Now, before I go into the various options you have for deployment, I'd like to go back to our demonstration code and talk a little bit about the Visual Studio environment that you're working in. So here's the example that we've been working with, and this was a website application. In fact, just to show you the flexibility, one of the things they did in Visual Studio 2005 was they shifted away from the project model in websites to the website model. And the motivation for that, let me just show you the flexibility of that model, is that you can literally walk up to any directory and open it up as a website. So if you want to, you can go open up Visual Studio, bring up the open website directory, and point it to any directory you want to on your machine. So just as an example, let's point this to our Windows directory, just for something different. And it doesn't have a config file. Let's not bother putting one in. And there we go. I've got my Windows directory opened up as a website. Now, probably not a great idea, but it just shows you the complete flexibility of the Visual Studio environment. In the past, specifically Visual Studio 2003, in order to open up a web project, you had to configure IIS properly and make sure the virtual directory pointed to the same physical directory that you're working with before it would even let you open a source code file and start working with it. So 2005 and still in 2008, they went in the opposite direction and just said, let's make this a useful utility for building websites and working with web content that doesn't get in your way as a developer. So you could just walk up anywhere and start working with stuff. And the other thing that's useful about this, and we've already seen this a few times, is that you don't even have to have IIS installed in your machine. As we've seen, if you run your applications in the default mode inside of Visual Studio, it's going to be running over a dedicated port that is not port 80. In this case, it's 1059. And it's listening, or it's running through this ASP.NET development server, which is just a process that is launched to listen on that dedicated port for you. So it's really minimal configuration, ease of use, ease of development, and not having to worry about details of deployment at that level. And if you want to, you can stick with this model for deployment as well. So the model for deployment, if you have a simple project like this where you're using the website model, could be something as straightforward as this. Let's just go create a web application to deploy this to. So I'm going to go to my default website and add a new application, and let's call this application deploy, and I'm going to put it in the top level C drive and create a new directory called deploy. And this is where you can imagine it being your target machine where you're deploying to. And let's go back to our site here, and literally all you need to do to deploy your website is to go into your website directory, which in my case is code test, copy the files, and you can use whatever mechanism you want to do this, paste them into your deploy directory, and you're good to go. So if I go back to my website here, switch over to content view, and view this defaulted ASPX file in the browser, there we go. We have our website up and running with all the functionality that we had been working on. So that's the Xcopy deployment model, which is the dead simple. What you have is what you get. Take your files, push them out to the directory, and you're done. Now, if you do want a little assistance doing that, and you're probably not going to be using an Explorer like I was just using, there is actually a utility here under the website option called Copy Website. And what you can do here is connect it to the directory, which could be on a remote machine or even over an FTP connection, and tell it that is the directory where you want to push your files to as you copy them to the live site. So I'm just going to select my deploy directory, and notice we have files in our local directory that we're going to push over there. And you also have the synchronization option, so you can actually keep them synchronized if you happen to modify them up there. But in the end, it's just a very simple layer on top of a copy mechanism. So there's nothing really that sophisticated about this utility. You could equally rely on any copy utility that you might favor. So that's copying. That's the source mode deployment, right? Literally taking files and copying them from one place to another. And again, whatever copy utility makes sense for you. There are two other options, however. So in addition to the source mode deployment, also known as Xcopy, there's a binary updatable and a binary non-updatable mode. And we'll take a look at these in more detail next. The binary mode is going to take all of your source code files and all of your ASPX files and compile them into assemblies so that you're only pushing assemblies up to the deployment directory. And this has some unique benefits, as we'll see. And then binary updatable mode does the same thing, but it leaves your ASPX files intact. So if you want to make small modifications to them on the deployed site, you're allowed to do so. We've now seen the source mode deployment, which is also called Xcopy deployment, just taking the files in your project and copying them to the deployment directory or machine. Let's take a look at the other two options now, which were the binary and binary updatable deployment models. Both of these rely on a utility that ships with ASP.NET called the ASP.NET compiler. And there is an interface through Visual Studio to access this utility, which I'll show you in a moment. But you can also do it or access it from the command line. If you want to write your own script files to precompile your site using this utility, it's quite easy to do. And there are two modes here. One, if you accept the default, it's going to be the pure binary model, which is just, it takes all of your content, including your source code files and your ASPX and ASCX files, and compiles them into assemblies and leaves literally no content as text on the deployed server. The other option is to use this one right here, the -u, which says leave my ASPX and ASCX files intact so I can make modifications to them on the deployed server if I want to make small changes. So let's go back to a demonstration here and try this utility out. Now to show you some of the features, I've created a new website. So this is a brand new website, and I've put a bunch of pages in it so we can sort of see what happens when you deploy these things. I've got a code file in here, very similar to the one we showed earlier, my utils, and I've got a couple of subdirectories with default pages inside of them. I've got a root level default.aspx, I've got a root global ASAX file, I've got a user control, I've got a couple of pages, and a config file. So that's the extent of my application. Now what I'm going to do, and let's just try running this so you can see what it looks like. So there's my deployed site, I've got a user control. What I'm going to do is compile this as a precompiled application and deploy it to that same deploy directory that we looked at earlier, which I have since emptied out. So there's nothing there now. And we've mapped our Internet Services application onto that directory, so we should be able to access it through a browser. So let's go ahead and run this utility now. So the utility is ASP.NET compiler, and if you just get the options for it, the examples at the very bottom give you some good examples to follow. They're often pretty close to what you want to do. Now what I'm going to do is use this last one, which does not rely on IIS. Instead, you give it a physical path to the directory that contains your application you want to compile. So I'm going to run ASP.NET _ compiler -v, the name of the app is deploy test, -p for the physical path that I want this to draw the application from is cdemos deploy test, and I want it to deploy it to cwhack deploy. So let's go ahead and run that. And once it is complete, we can go look in that deploy directory. There's the output. And if we go run it from our IIS installation, there's the files. Let's go ahead and run it. Notice it looks exactly the same. Okay, so that's a good sign. Now, what's different about the deployed files with that binary deployment, binary compilation? Notice we have no source code files. So if you look back in the original project, all of these pages had code behind pages associated with them. So those are gone. And also we had this app code directory. That is also gone. So all of that has been replaced, all the source code files have been replaced with a bin directory with a collection of assemblies inside of it, as well as some other stuff that we'll take a look at in a moment. So all of those things were precompiled. Notice the app code directory got its own assembly. The global ASAX directory or file got its own assembly. And then these are assemblies that were generated from various code files in different directories in this site. Now, we did say this was binary only, so it's sort of curious that we see these ASPX files in place. Now, the ASCX file is definitely gone, so that was the user control over here. That's gone because it just became a binary file only. But if we open up one of these files, notice that these are really just marker files that are generated for us by the utility, and they have none of the original content. All of the content has been compiled into the assemblies. Now, if we wanted the content to remain there so we could make small changes to the UI once we had deployed it, we could do that as well just by running the same utility again and specifying the -u option to make it an updatable site. So we run it as an updatable site, go look at the deploy directory, take a look at one of these files, and you'll notice the content is still there, which means I could make modifications to the elements in the site or in the page. But notice that it did tweak the page directive at the top here. It's got the inherits element, but it does, or property or attribute, but it does not have the code file attribute that is there by default in the ASPX files. Also notice it's referencing a specific assembly, which was compiled as part of that precompilation. So those are the two variations in deployment. You can either do all binary or partial, updatable binary, which compiles all your source code but leaves your other files intact. Notice that updatable model also left my user control in place too, the ASCX portion of it. So if you wanted to make small changes in the look and feel to that, you could do so as well. Now I should note that all of these models are essentially equivalent performance-wise once things are up and running. So there really is not a distinction between all binary, updatable binary, and all source in terms of performance once the site is up and running. Now there will be a little bit of a performance difference between the binary and the source mode on the first request made to the site, because that's when the compilation will have to take place for the source mode and will have already taken place for the binary mode. So you might see a little bit of performance improvement on the initial requests made on a per directory basis once you deploy the site. But once it's up and running, there really is no difference. So you should choose the model that best suits your needs. And a lot of people just stick with the source model because it's convenient, it's easy, you know exactly what's being deployed. Other people are more interested in making sure their site is not easy to modify once it's been deployed, in which case the binary is ideal for that, because you can't actually make any changes to it unless you go back and recompile the original source for all of the pages. If you were paying close attention in that last example of the binary deployment, you might have noticed that there seemed to be something missing, which is how were the requests actually getting routed to the endpoints if the files were no longer serving that purpose of endpoints in the system. And to illustrate that, let me go back again to our example here. And what I'm going to do is redeploy the site as a binary-only deployment. And instead of using the command line like I showed you before, let me show you how to do it within Visual Studio. So if you go to the Build menu, there's an option here, Publish Website, which will invoke the ASP.NET Compiler utility for you. And you can specify the target location here. And this is the equivalent of the -u option for allowing the site to be updatable. So I'm going to uncheck that to make it binary only. And that will compile and deploy the site, deleting the ones that are there already. And what I want to show you is if we go to the compiled site and actually get rid of all of these files. So notice all the files that are in place there. If we get rid of them all like this, all we are left with is our configuration file, our bin directory, and this config file that's used for pre-compilation. And that's actually a valid deployment of this site, completely taking away the source code, the ASPX files. And just to show you that, let me go ahead and run the site through IIS. So I'm going to go to HTTP, localhost, deploy, and get to the root site here. So I'm going to go to localhost, deploy, default.aspx to go get to that root file. And notice that seems to work fine. And then let's try going into a subdirectory. Okay, so we had a subdirectory /default.aspx. That works fine. We could even go to that nested subdirectory, sub/sub/default.aspx. That works fine. And if I go to page1.aspx, that also works fine. So everything, all the endpoints are working fine, even though we have no physical files on disk corresponding to all of these endpoints. And the reason for that is part of the binary deployment was a collection of .compiled files that you see in the bin directory. And if you open one of these up, you'll get a sense for what's going on here. So open this up and take a look at what's inside here. It says, look, if you ever get a request that goes to this application under sub/default.aspx, then I want you to go and locate this assembly, and inside of that assembly, go find this class definition. Whoops, go find this class definition. And that class definition is the one you want to create an instance of to dispatch this request onto. So that's the endpoint mapping that needs to be in place for the pure binary deployment to work. So as you push this project out to a deployed server, make sure you don't delete those .compiled files, because those are critical for the operation of the site to work. The one other thing to note is that there was a reason that it did generate those empty files for us. And the reason is this. If you have the default document mechanism in place in IIS and you want to be able to go to your application, localhost/deploy, without any /default.aspx, that's not going to work in IIS because there is no default.aspx file. In order for that to work, you need a default.aspx file, even if it's empty. So there is a physical file on disk, like so. And we go back and hit this page again, and now it works fine. So that is one reason you may want to keep those files in place, but you probably don't, or you definitely don't need to include like page1.aspx, page 2, etc. But if you want the default document mechanism to work properly, IIS relies on a physical file being in place. So you probably want to keep those, at least those files, on the disk. If you do end up using binary deployment for your deployment option, there's another thing you need to think about, which is the packaging granularity, which is to say, how are all of your files being compiled into assemblies, and how many different assemblies are you actually going to end up with when you're doing your deployment? And this is important because as you're doing updates to your site, how you actually package your stuff up is going to matter when you need to make changes. So there are actually two options by default. The default option, which is the one that we just used, perhaps unknowingly, is to create a single assembly per physical directory. So you have one assembly per directory in your web application. So if you have multiple subdirectories, each of those will get their own assembly. Plus, you'll have a separate assembly for global ASIX, a separate assembly for app code as well. So each of those will be dropped into their own assembly. And those assemblies are going to be named something different most of the time. Now, the app code actually ends up being the same thing each time, as does the global ASIX, but all of your directory assemblies will be regenerated with new names every time you update. The other option is to use the -fixed names attribute or option in the ASP.NET compiler utility. And this will actually generate a distinct file, a distinct assembly per ASCX file or ASPX file. And that has the advantage of naming them the same way every time. So if you only update one file inside of a directory, you can actually just deploy that update to your live server. But of course, it has the drawback of creating a rather large number of assemblies if you have any significant number of pages in your site. So you want to use that one cautiously. Now let me just show you this in our example. So go back to our demonstration code here. And you can see in my application, I have the app code directory. I have 2 subdirectories as well as the root directory. And then I have global ASAX, and I have, yeah, that's it. So if I go to the deployment, look in the bin directory, you'll notice the assemblies here. There's the app code, there's the global ASAX, and then I have 4 distinct assemblies that include all of the root directory, the 2 subdirectories, and the third one will include the user control. That's actually dropped into its own assembly as well. So as long as you're in release mode, you're going to get a separate assembly per directory, plus 1 for the app code, the global ASAX, etc. But again, these are all going to be named differently every time. So if I do a redeployment of this site, all of these assemblies are going to be renamed to something new. So if you're going to push that out to the live server, you'll need to make sure to delete everything that's there and then push out all these updated files. So, so everything is in sync and you don't have redundant definitions of classes. The other option, like I was describing, is on the deployment, the compilation here. When you do the publish website, you can check on the use fixed naming and single page assemblies. And that's going to increase the number of assemblies that are generated as part of the compilation. So if we go out to the site again here, look in the resulting collection of assemblies, and you'll see not only do we have those 2, but we have 1, 2, 3, 4, 5, 6 separate assemblies. But notice this time they don't have that gibberish as part of their naming convention. It uses just the actual name of the file plus an extension there, and that will be the same each time you recompile your site. So you could push out 1 assembly at a time if you wanted to. But most sites that I've worked on, I would not recommend that, just because you'll end up with potentially hundreds of assemblies, and that really is not the optimal mode for deployment. So each of these options has their drawbacks, potential drawbacks. With the first method, every time you compile, you get a new set of assemblies, and you have to make sure you completely delete all the old stuff and bring in the new stuff. With the second model, you're going to have a lot of assemblies. So each of these is, perhaps not ideal, but fortunately we're going to have a way to address it. We will come back to the issue of packaging granularity in just a moment with another solution for you. But let's talk about a couple other issues that are also cropping up. And these are with the website model in Visual Studio. You might have noticed when you're working with a website that while you do seem to have a set of options for the project, for your website, they're not the same set of project options you have for other projects, like a class library or a WinForms application. And the reason for that is there really is no project there. All you're doing is making some changes to a configuration file or other settings that are stored for you, and it's not a real project file. And this has some implications that may not be desirable. One is that the ability to exclude files from the compilation process is, well, there technically is a way to do it, but it's really a hack. All you do is go in and change the extension of a file to something from ASPX or CS or VB to .exclude, and Visual Studio will ignore it. So that works, but it really doesn't feel like a real project inclusion, and it also makes it difficult to exclude entire directories. You actually have to go into each directory and rename all of the files to be a .exclude, and that's just not really feasible. There's also no way to add pre or post build steps. So if you're used to using project files with these pre and post build steps as part of the compilation process, those are not there because there is no real compilation going on. And there's no way to switch between debug and release builds on the command line. The only way to switch is to go into your web.config file and change the compilation setting from release to debug or vice versa. The other potential drawback is the partial sibling classes, the ones that contain the server-side control variable definitions, are generated only at compile time or request time, and you never get to see them. So Some people find that disconcerting, the fact that you're relying on features that are added to your class later and you don't actually see them. And another thing that comes up is the migration from the 2003 model of Visual Studio for websites is all or nothing, right? If you're converting a 2003 web application, web project to the website model in 2008 or 2005, it's going to force you to turn all of your files into the new partial class code model, and with no other options. And if it's a very complex site with a lot of code files and inheritance and such, it may not always work entirely properly either. So just to demonstrate a couple of those things, let me show you what I'm talking about. So here's looking at the properties for my quote project. Notice this is very different from the property dialog you get with a standard project, because this is really not a project. And if you think about it, what happens when you do a compile here? Right? When I'm doing a compile, usually you see a byproduct of the compilation, but in our case, there is no byproduct, right? There's no output to a bin directory. There's no binary assembly being generated that we can see. It really just does the equivalent of issuing a request to all of the directories in your site to make sure everything is compiled properly, or will compile properly once it's deployed. And then here's the issue I was talking about, excluding things from a project. So if I didn't want to include this source code file from the project, I could exclude it, but notice what the exclusion does. It actually just renames that file to be a .exclude. So that's their solution to excluding files from part of the project. Similarly, if I wanted to exclude an entire page, you could just rename it with a .exclude extension and it would achieve the same effect. So feels kind of cheesy if you're used to using real projects and you don't have all those features that we talked about, the pre and post build step and all the other project-related features of a application. So a lot of developers really wanted that back as they started working with websites, and fortunately, they have released a addition that gives it back to us. So the solution to some of the deficiencies of the website model are addressed with the introduction of web application projects. Now, these were released about 6 months after the initial release of Visual Studio 2005 as a separate add-on project type that gives you a project much closer to the 2003 project model. So it does have a real project file. All those things we talked about in the previous slide are no longer true, so you can actually add or include things as part of the project, have the pre and post build steps, set the compilation mode without making modifications to config files, etc. And it also included a couple things that were quite nice. It does not require any virtual directory dependencies. So you don't have to have IIS set up for this to work. It works equally well with the ASP.NET development server as it does with IIS. So that works fine. It's also easier to migrate large sites with this. If you're coming from 2003 at all, you can open those up as web application projects in 2008 and then migrate your pages one at a time if you want to, instead of converting them all to the new partial class model. Or you can leave them as is and it still works fine as well. It also resolves some compilation issues that people have had with the website model, where there are occasions where you can get into a cyclic dependence that is hard to resolve with the default compilation model in a website that can go away with a web application project. And it also generates those partial sibling classes explicitly, as you'll see. So let's go try this. By the way, this is included with Visual Studio 2008, and it was also included with 2005 with the release of SP1. So let's go try out a web application project. So instead of creating a web site, you're going to choose project this time. And then under web, you'll find the ASP.NET web application. And let's just call this our WAP test. And this will generate a new website for us. And it feels pretty familiar, but if you look at the properties of the project now, notice they are a full set of properties with a set of build events, the signing of the assembly, the deployment, the pre and post build steps, etc. So you get the full project going on. Also, notice there's no app code directory. If I add a new class to my project, it's just added as a class to the project. And if I wanted to exclude that class from the compilation, I would exclude it, although it would physically still be on disk. So just like a normal project, it lets you include and exclude elements from the project file. The other thing you'll notice is the code behind file. Here's the code behind, but there's another file that's included, which is the designer file, and that's going to contain all of the variables that need to be generated for server-side controls that are added to your page. So for example, if I go to my page and put a button on here and a text box, I should now have member variables placed into this class corresponding to those two controls. So there's my button and there's my text box, and each of them has the names of the identifiers on the server-side controls. So this was something that only happened at request time in the website model, whereas in Visual Studio, the web application project model, it happens during development time. You actually see the file being generated. It still does use a partial class. Here's the code behind, and here's or the partial class, and here's your code behind. So it is being merged, but it happens during the compilation of your site. If we go ahead and compile, do this build compile, notice the output is in fact an assembly. So it actually compiles the resulting, all the source code files into an assembly, and that is part of the content that you need to deploy as part with your site. You'll also notice if I go to the build publish menu that I don't have all the options that I had before, because you're really sort of choosing the model where you compile all your source code into an assembly and take all your ASPX and ASTX files and deploy those separately or live to the server without making modifications. So it doesn't have the option for the binary only deployment, although I'll show you in a few minutes a way to get around that if you want to. So it kind of ties you to this model, but again, a lot of people are very happy with this model, and there's no reason to migrate away from it. So that's the web application project. The other advantage is sometimes this is easier to integrate into source control systems because you do have that real project file, and it's not just a bunch of files sitting on disk, which you know are going to get compiled a certain way when a request comes in. So now that we have web application projects and websites, it feels like we have something to please everyone, right? Depending whether you're enterprise style developer that wants to have projects and make sure you have all those features related to projects, or if you just want to open up directories and start typing code, those are all supported. But there do seem to be a few holes still missing. We talked about some of the issues with the packaging, the granularity, which we don't have a lot of control over. It was either one assembly per directory, or it was one assembly per file, and sometimes it might be nice if we could have something in between those two. And then there are other issues now that we have these two different compilations models where the web application projects only give us one deployment model. So we don't have the pure binary model like we had with the website. So wouldn't it be nice if we could deploy in whatever mix match of binary / source we wanted to, regardless of which project type we used, and we could control the name of the generated assemblies, so we didn't have those arbitrary names generated for us. And we could consolidate many assemblies into a single assembly for a more atomic deployment. So as you packaged up your assemblies for deployment, if you reduced all your code into a single assembly, you know that would be pushed out in a single copy operation, and you wouldn't have requests coming in that would be accessing stale data. So the solution to this is web deployment projects. And this is another add-on that was released, and it gives you the ability to basically solve all these issues. So how do these work? These are another project type. So when you use web deployment projects, you're going to be adding another project to your solution. And it's basically just an MS build file that will describe how you want to deploy the output of your web application, whether it's a website or a web deployment web application project. It's included with 2008 with the release of SP1, and it's an add-on for 2005, available for both. And it is a solution for each of the things we talked about in the last slide. So it consists of a set of build tasks and a Visual Studio add-in to make it easy to set up. It generates a script to invoke the ASP.NET compiler, and there's another utility we'll talk about in a second called ASP.NET Merge, which will actually take assemblies and turn them into a single assembly. And the options for deployment include a superset of the compiler that we looked at earlier, which includes binary only for the separate assembly per directory, and also one assembly for the whole site. And that was the piece that was missing before. It also supports the updatable model. So let's go ahead and try this out. Here I am in my web application project. I think what I'll do is go back to the website though. Just be aware that it works equally well in either environment. It's not a problem. So I'm just going to go open up the website that we were working on before, which was under deploy test, just because I had more content in this one. So here's how you work with web deployment projects. Right-click on your website or your web application project and select the Add Web Deployment Project as an option. Give it a name and put it into typically a sibling directory. So I'm going to drop it into the same directory as actually a directory above my deployment directory. We'll just call it deploy test _ deploy. And if we get the properties for this guy now, set the output folder to our deploy directory up in the root of the C drive. This is whether you want it to be updatable or not, so you can check that or uncheck it. And here's where it gets a little bit different. Notice the output assemblies, by default, it's going to merge all of the assemblies into a single assembly for deployment, although you do still have those other two options that we looked at earlier. You also have a signing option if you want to assign your assembly, so you could deploy it in the GAC potentially, or just version it. And then we'll talk more about the deployment options available here in a moment. Another nice thing here is you can set up configuration settings so that only certain things happen during debug mode versus release mode. So in release mode, maybe that's when we actually do the binary compilation and deployment. But in debug mode, I don't want to do the deployment, so I won't actually execute the build process, the deploy process. Okay, so let's close that out. And let me go ahead and get the properties for this one more time and change the active setting to release so it will push out the deployment. And now let's go ahead and build our web deployment project. And what we should see is up in the deployment directory, the output of the compilation. And if you look in the bin directory, notice we're reduced to a single assembly. So that was the result of combining all the assemblies into one. We'll take a look at how that worked in a few minutes, but the end result of your web deployment project, if you choose that option, is to give you a single assembly that has all of your website source code files and all of the ASPX and ASCX files embedded inside of it. One of the major features of the web deployment projects was the ability to consolidate all of your assemblies into a single assembly for deployment. And it's kind of interesting to look at the technology behind this. It's actually something based on a utility called ilmerge, which came out of MS Research. And ilmerge you can download if you want to go look for it. It's on the MS Research website. Is a utility which takes any two arbitrary .NET assemblies and merges them into a single assembly, or more than two even. You can have 3 or 4 or whatever. Now, of course, there may be issues that prevent you from doing that. If you have, classes that are named the same thing, or you have other colliding issues, it'll fail. But as long as everything can coexist, it works great. And what they did in web deployment projects was integrate it into their a new utility called ASP.NET Merge. And you might find this of interest on your own. ASP.NET Merge will walk up to a directory that contains a website, an ASP.NET website, and you can tell it to go through its bin directory and merge all the assemblies into a single output assembly. So I thought I might just show this to you as a quick example. So let me go back to our website here. And I'm not going to run the web deployment project, but rather I'm going to deploy the website like we did earlier by using the publish website option. I'm going to leave it as not updatable. And let's not use, let's use the fixed naming. You can see the merging of a whole bunch of assemblies here. Okay, so the result of that should be a bunch of assemblies in the bin directory, right? We got a whole bunch there. So let's go to our command line now, and I'm going to run ASP.NET merge And you can see the command line there. So I'm going to do an ASP.NET merge, do a -o, and we'll call this myapp.dll is fine. And the target directory is our deploy directory that we just did the binary compile to. And what that should do is churn through that deploy directory, taking everything in the bin and merging it into a single assembly. And that's exactly what you see here. Okay, so that will that has the effect of merging it all together. And usually you won't have to do that because you'll probably be using the web deployment projects, which do it for you. They have a special build step that invokes that utility for you. But in the chance that you ever find that useful, the utility is available and installed as part of the set of utilities available for ASP.NET. There's one more feature of the web deployment project that you might find useful, and that's the support for pluggable configuration files. And the way this works is you can set up a section of your configuration file that you want to have replaced depending on which configuration you're currently targeting, whether it's debug or release or maybe a stage configuration. And what you can do is create several different files containing the section of the configuration file you want to have replaced, and then you associate one of those files with a connection or a section of the config file. This can be any section of the config file. And you create a different one of these for each active or each configuration setting, debug, release, etc. And then depending on which mode you're in, whether you're in debug or release or some other mode you might have created, it will pluck out the contents of these files and drop them into your web.config file, replacing the section specified right here with the contents of that file. And this can be useful because very often, especially for things like connection strings, you very often have a different set of connection strings that are used during debugging or on stage testing than you do for release. And you often have to do that manually or have to come up with your own replacement mechanism. And what they've done here is given us an automated way of doing it. So let's go ahead and try this out. Here's my project. And let's go into my config file and actually put something in that's worth replacing. So let's go to my connection string section, which is probably the most common thing you'll end up using this for. And let's put an add name equals foo and connection string equals bar. Just keep it really simple for now. So there's my connection string, and I want to replace this with a new piece of content, depending on which mode of operation I'm in, which mode of deployment. So I'm going to go ahead and add a new text file to my site here, and we'll call this debug cs.config. And we'll paste that in, and let's just change the connection string here to be debug :bar. Again, it's not a valid string, but it'll get the idea across. And let's also save this as a release version, like so. Okay, so those are the two versions of my connection string section that I want to have replaced anytime I actually run the web deployment project. So let's go wire that up in the web deployment project now. Go get the properties on the web deployment project. And let me go actually set the configuration manager to run this during debug so we can see the output as well. And finally, go to the deployment model. And during debug, we're going to turn on the config file replacement. And I want connection strings to be replaced with the contents of debug cs.config. Okay, we'll apply that, and then we'll switch over to release mode. And we're going to do the same thing. Connection strings is going to be replaced with the name of that file. Let's make sure we get it right. Release cs.config. Okay, and that will copy the contents of this file into the connection string section as it copies the web.config file out to the deployment directory. So currently we're in debug mode. Let's go ahead and try compiling our web deployment project in debug mode. And that should push a bunch of new files out here. And if I open up the config file inside of deploy now, hopefully we'll see that connection string section replaced with our debug contents, and indeed we do. Good, so that worked. Let's go try the release version now. So I'm going to switch over to release mode. And if I compile this in release mode, that should use the substitution with the release CS config file. And once that finishes, if we go open up the web.config file here, we should see still shows debug. Oh, you know what? I didn't change the release version of the config file. Hold on. So we need to update the contents here to say release so we can see something different when the release file actually pushes out there. Let's try that one more time. So we're in release mode. Good. We compile it. That will run through the binary deployment. We go to the deploy directory. When it's done, we take a look at the config file. And this time, we see the different version of the connection string, the release version. Okay, so you can substitute any portion of the configuration file with contents from a distinct file depending on which mode of compilation you're in using web deployment projects. Hi, this is Fritz Onion with Pluralsight, and in this module I'll be looking at the deployment options that you have when you're taking your ASP.NET applications to a live server. We're going to start with a look at how to package your code. There are several interesting ways to include code as part of an application in ASP.NET, and we'll look at each of those in turn, starting off with the simple deployment to the app code directory, and then looking at creating a separate class library that you reference in your bin directory. And finally, we'll talk about using shared assemblies that you might want to deploy machine-wide in the global assembly cache, and how you could manage those and potentially version them. Then we'll switch over to looking at the actual deployment of an ASP.NET application. We'll talk about the web site model that is the default model for building applications in Visual Studio, and talk about the various deployment options you have when you build applications using that model. And those options will include the traditional Xcopy model, the just source deployment, the binary model, which is a newer model that was introduced in ASP.NET version 2 that lets you deploy only binary components to the deployment directory. And finally, there's a hybrid of the two called the updatable model, which will compile all of your source for you, but leave your ASPX and ASCX files intact for updatability. Then we'll shift on to looking at a couple of newer features that were added to the deployment model in ASP.NET, including web application projects, which is an alternative to building website applications in ASP.NET. We'll talk about the differences and when you might want to choose web application projects over the traditional website model. And then finally, web deployment projects, which again is another newer feature for giving you more options basically when you are actually deploying your site. And we'll tie this back into the deployment options we mentioned earlier and what additional options web deployment projects give you